Do multilingual models that recognize language-specific units work on all speech? Well, not really, because to be truly universal, we should be able to encompass not only speech from any language, but also we should be able to capture variations in speech with accents, and we should be able to handle languages where we might not even know the written forms. So this is where systems that are built to predict language-specific units like surface level or phoneme units would fall short. Alternatively, we can build systems to predict units that are actually agnostic to any particular language. For example, in this work, we focus on phones. So the next question would be, how do we obtain supervision at the phone level? One way that people have done this is to actually manually annotate. In this work, we consider another approach, which is to simply approximate the phone level supervision from phoneme annotations, where phoneme annotations can be obtained via automatic graphing to phoneme tools. Then all we would need are phone-to-phoneme mappings to relate the supervision signal back to the phone level. So what's happening is we're defining phone realizations of each phoneme for each language. And what we end up with is for each phone we're mapped to many phonemes, and also vice versa, a phoneme could be mapped to many phones. The scenario is actually pretty manifold, and there's a lot of ambiguity here that can cause confusions at both the phone and the phoneme level. So what we need to do is encode the phone-to-phoneme mappings in a way where we can learn some disambiguations. And what we do here is we define these allophone graphs, which are WFSTs that are single state, where a transition and corresponding wave function tell us the likelihood that a phone is a realization of a particular phoneme. Then we use these allophone graphs to accept phone emissions, transduce them into phoneme emissions through WFST composition, and we can put these allophone graphs within a multilingual model where we can learn a single shared universal phone output representation and language-specific phoneme representations. What we end up with is allophone graph weights that are interpretable. And we also find that models using these allographs result in fewer substitution errors and also less severe substitution errors than models where we simply use a pass-through matrix to represent the mappings. So please check out our full work for description of the methods, results, including both phoneme recognition and also discussion about confusion pairs, qualitative examples, and we also look at linguistic applications of this.